Welcome to my Ultimate Design Patterns course. I'm Mosh, and I'm super excited to be your instructor. Let me give you a quick overview of what this course is all about and what you need to know before you get started. In this course, you're going to learn how to design reusable and extensible object-oriented software. In order to take this course, you should have at least 3 months of programming experience. It doesn't matter what language you're familiar with, you just need some basic programming experience. Also, if you're familiar with basic object-oriented programming concepts such as classes and interfaces, that will be great, but not required. I'll give you a basic overview of these concepts in the next section. Now, before we get started, I want to set the expectation. In this course, we're not going to work on any algorithms. You're not going to see me working with loops or if statements or implement complex logic. That is not the purpose of this course. I've covered all the algorithmic topics in my data structures and algorithms course. Also, we're not going to build an application. Instead, we're going to talk about designing object-oriented software. We're going to talk about how you should structure your classes and how these classes should collaborate. Our focus will be on building reusable and extensible software. Software that can be easily extended. The techniques we're going to cover in this course are extremely important, and every software engineer working with object-oriented systems should master this. So I'm super excited to be your instructor. Design patterns is one of my favorite topics, and a lot of you guys have been waiting for this course for a long time. So let's jump in and get started. You might ask, what are design patterns? Well, design patterns are elegant solutions to repeating problems in software design. For example, you may want to implement the undo mechanism in your application. That's a repeating problem in software design, right? Now, we have a couple of different patterns for implementing the undo feature. One of them is the memento pattern. So a design pattern shows you how you should structure your classes and how these classes should talk to each other. Now, in this series, we'll be exploring 23 design patterns that were originally documented in the 90s in the book called Design Patterns: Elements of Reusable Object-Oriented Software. The book was written by 4 authors that are known as Gang of 4. So quite often we refer to these patterns as Gang of 4 patterns. The Gang of 4 patterns include 23 design patterns in 3 categories: creational, structural, and behavioral. Creational patterns are all about different ways to create objects. Structural patterns are about the relationships between these objects, and behavioral patterns are about the interaction or communication between these objects. In the first part of this series, we'll be talking about the behavioral design patterns. And by the way, these design patterns don't represent all the patterns in the world. There are many unofficial and undocumented patterns out there that you might find useful in certain situations. But these 23 design patterns are the classic ones that every software engineer must understand. One of the benefits of design patterns is that they help us communicate with other developers at a more abstract level. For example, you may tell your coworker, hey, we can use the command pattern to improve this code. You can simply use the name of the pattern to communicate the idea. You don't have to write a lot of code to express that idea. Another benefit of studying and understanding these design patterns is that it makes you a better designer. You will learn how to build reusable, extensible, and maintainable software, no matter what programming language you use or what kind of applications you build. And finally, another benefit of learning design patterns is that they help you learn and use new frameworks faster. One of the questions I often get is, Mosh, how do you learn various things so quickly? I tell you what, I'm not a genius. Yes, I do have years of experience. In fact, I started programming when I was 7, and now I'm 37. But one thing that I believe has helped me enormously is understanding these design patterns, because I see these design patterns used in various frameworks and libraries. So every time I learn a new framework, it kind of looks familiar to me. It's just a different syntax that I have to memorize. So these are the benefits of learning design patterns. Unlike other courses and books that teach you design patterns like a list of recipes to follow, in this course, I'm going to teach you the art of designing object-oriented software. So I'm not going to give you a catalog of design patterns ordered alphabetically. I've specifically ordered the patterns in this course to teach you various important concepts. So even though you can jump to a specific pattern to learn more about it, it's best if you take the course from the beginning to the end. Because throughout these sections, I will talk about various principles, and if you skip those, you're going to miss out a lot. So if you want to get the most out of this course, watch all the sections in order. Every section is short and sweet, and you can watch it in half an hour or less. If you have taken any of my courses, you know that I don't waste your time by long, slow, and repetitive explanations. Also, in this course, I'll be using Java, but you don't have to be a Java developer in order to take this course. In the next section, I'm going to give you a quick overview of the Java syntax so you can easily understand the code we write. If you use Python or C# or some other language, you can take the concepts in this course and apply them in your favorite programming language. Again, our focus is on the art of designing object-oriented software, not a particular programming language. Now, if you are a Java developer, I still encourage you to watch the next section, even though it may appear a little bit basic for you, because in the next section, I'm going to talk about the essential object-oriented programming concepts such as encapsulation, abstraction, inheritance, and polymorphism. A lot of developers don't really understand these concepts properly. So I will see you in the next section. In this section, I'm going to give you a quick tour of Java and the essential object-oriented programming concepts you need to understand in order to take this course. We'll be talking about classes, interfaces, encapsulation, abstraction, inheritance, polymorphism, and UML, which is the graphical notation we'll be using throughout this course. If you know Java, you can skip the first video or two where I create a new project and show you how to work with a class. But I highly encourage you to watch all the other lessons, especially the lesson about interfaces, because interfaces are one of the most misunderstood concepts in Java and in many programming languages. Also, make sure to watch all the other lessons such as encapsulation, abstraction, inheritance, and polymorphism. These are extremely important. I want to make sure we're on the same page and you really understand what these concepts are. If you don't understand these concepts properly, you're not going to be able to understand design patterns. So let's jump in and get started. All right, in this course, I'm going to use IntelliJ, which is a very popular Java IDE, but you can use any IDE that you prefer. If you want to use IntelliJ and code along with me, you can get it from jetbrains.com/idea/download. It comes in two editions, Ultimate, which is paid, and Community, which is free and open source. Here in IntelliJ, let's create a brand new project. So we select Java on the left. Next, we select Create Project from Template. We want to create a command line application. Next, we should give this project a name. Let's call it Design Patterns. Over here, we should specify the base package name. A package in Java is a container for one or more classes. In some languages like C#, it's called a namespace. So here we should type the base package name. By convention, we use the reverse domain name. My domain is codewithmosh.com. So here we have com.codewithmosh. This is just a convention. It doesn't mean you should have a domain name registered on the internet. You can type anything here, okay? All right, as you can see, every Java project has this main file, main.java. And in this file, we have a class with the exact same name. This class is declared in this package, com.codewithmosh. So the package statement on top of the file determines where this class is going to be defined, okay? Now in this class, we have a method called main. Both this method and this class are declared as public. This means they're accessible anywhere in this code base. We'll talk about this later in this section. Now the main method is declared as static. This means we can call this method directly without having to create an instance of the main class. Void is the return type of this method, which means this method is not going to return a value. And here in parentheses, we have the parameters of this method. In this case, we have a single parameter, which is a string array called args. If we execute this program from the command line and pass a few different arguments, we can capture those arguments using the string array, okay? Now, in Java, we use curly braces to represent a block of code. And by convention, we put the left brace on the same line. In some languages like C#, we put the left brace on a new line, but this is unconventional in Java. So let's bring it back where it was. So this is the basics of a Java program. Next, I'm going to show you how to create and use classes. All right, let me show you how to work with classes. So in the project window, we expand the project folder. Here we have the source folder. This is where we have all the source code for this project. In this folder, we have our base package, which contains the main class. Now we right-click the package name and add a new class. We're going to call this user. In this class, we can have fields or attributes for storing data and methods. Let's declare a field for storing the user's name. So public, string, name, and we terminate it with a semicolon. So in Java, we terminate our statements with a semicolon. Now, technically, this is a bad practice to declare fields as public. I'm going to talk about this later in this section. For now, let's declare everything as public. So string is the type of this field, and it's called name. Now we can go to the main class and create a new instance of the user class. So we type user equals new user. So we're declaring a variable called user. The type of this variable is our user class. And here we're setting this to a new instance of the user class. Once again, we're terminating the statement with a semicolon. Now, using the dot operator, we can access the fields and methods in this class. So we can set the name field to Mosh. And once again, we terminate this with a semicolon. Note that in Java, we use double quotes to surround strings. Now we can print this field on the terminal. So we have the system class. This class has a field called out. This is an object that has a method called print line. This is like console.writeLine of C#. Now here we can pass user.name, and then we can run this program using Control and R. There you go. So here's my name on the terminal. Beautiful. Now we can specify the name when creating a new user. So we go back to the user class. We add a constructor. A constructor is a method that gets called when we create a new instance of a class. So here we type public, then we type the name of the class, and then we add parentheses. This is where we can declare parameters. Next, we add our curly braces. So let's add a parameter here called string name. Now we can set the name field to the value of the name parameter. However, both the parameter and the field have the same identifier. So if we type name equals name, the Java compiler thinks we're referring to this name parameter. So on the left side, we should prefix this with this dot. So we're saying set the name field of the current object to the value of the name parameter. So this is a reference to the current object. If we type this dot, we can see all the fields and methods in this class. Okay? Now, back to the main method. When creating a new user object, we can pass the name. We don't need to set it explicitly. And then we can print it on the terminal. So run. We get the same result as before. Beautiful. Now let's add a method in this class. So we start with public. We don't want to return a value, so we use void. We call this method say hello. And here we're going to print a message like, hi, my name is, and then we can combine the string with the value of the name field. Now in this context, we don't have a name parameter, so we don't have to use the this keyword. We can simply reference the name field directly. Okay. Now, back in the main method, instead of printing the name of the user, we can call user.sayHello, then run, and we get this message. So this is how we can create and use classes in Java. One of the important concepts in object-oriented systems is coupling, which determines how much a class is coupled or dependent on another class. For example, here in the main class, we're using the user class. So the main class is coupled or dependent on the user class. So if we change the user class, the main class might be affected. We may have to change it, or at least we have to recompile and redeploy it. Let me show you. So I'm going to go back to the user class and introduce a new parameter in this constructor. Let's say integer age. So we have changed the user class. Now the main class is broken. We cannot compile this code. We have to pass this argument over here. So this is the problem with coupling. Let me show you another example. Back in the user class, let's add a hyphen before this message. Now, back in the main class, we don't have a breaking change. Our code compiles perfectly well. However, because we have changed the code in the user class, this class has to be recompiled. And that means all the classes that are dependent on this class have to be recompiled as well. Now, this is a very simple program. We only have 2 classes. But what if we had hundreds or thousands of classes and many of them were highly dependent on each other? In an application like that, if we change a class, we could end up with lots of cascading changes. An application built this way is really hard to change, hard to extend. Let me give you a metaphor. Think of your car. If you get a flat tire, you only need to replace that tire. You don't need to replace the steering wheel or the engine, right? Your car is an example of a loosely coupled system. The components in your car work together, but they are not tightly coupled or dependent on each other. So you can replace individual parts independently. Our applications should be the same way. But how can we build loosely coupled applications? Using interfaces. And that's what I'm going to cover next. Interfaces are one of the most misunderstood constructs in Java and in many other programming languages. I talked about this in detail in the second part of my ultimate Java course that is about 4 hours long. But let me explain it very briefly. An interface is a contract that specifies the capabilities that a class should provide. Let me give you a metaphor. Imagine you want to open a restaurant. You need a chef. It doesn't matter who the chef is, so you're not dependent on a particular chef. You're only dependent on someone who can perform the role of a chef, someone with certain capabilities. This is an example of a loosely coupled system. Now, I told you that an interface is a contract that specifies the capabilities that a class should provide. So in this example, we can represent the role of a chef with an interface and the actual chefs with classes that implement the chef interface. So this is the idea behind interfaces. With interfaces, we can build loosely coupled applications. Let me show you this in code. So let's say we want to build a tax calculator. Tax calculation is complex and the rules may change from one year to another. We can have a calculator for year 2019 and another for year 2020. Just like we can have different people filling the role of a chef at a restaurant, right? But what do all tax calculators have in common? They probably have a method called calculate tax. We can represent this with an interface. So in this package, let's add a new class. First, we change the kind to interface and call it tax calculator. So this is just a contract that specifies the methods that our calculator classes should implement. So here we add a method, float calculate tax. Note that we only have a method declaration. So we are terminating the statement with a semicolon. This method does not have a body. It doesn't have implementation. If we add curly braces here, we get a compilation error. So this interface is saying, hey, if you want to build a tax calculator class, that class should have a method with this signature, okay? Now let's add a real tax calculator in this project. So we add a new class. We call this tax calculator 2019. Now over here, we type implements tax calculator. Now we have a compilation error because we haven't implemented the calculate tax method in this class. We can put the caret over here, press Alt and Enter, and select implement methods. IntelliJ added the calculate tax method in our class. Now don't worry about this override. This is called an annotation. I talked about this in the second part of my Ultimate Java series. For now, all that matters is that this class has a method with this signature. So here we can return 1. Now let's create another calculator. So once again, we add a new class. We call it tax calculator 2020. Once again, we say implements tax calculator. Then Alt and Enter, implement methods. Beautiful. Now in year 2020, we can return 2. So we have 2 different implementations of this interface. Now in our application, instead of working with these concrete implementations, we should work with this interface. This is called programming to an interface. So anywhere we need a tax calculator in this program, we're going to work with this interface. For example, we can go back in the main class. Let's add a public static method. I made this static so we can call it directly from the main method, okay? Now this method should return a tax calculator. So here we're using our interface. Let's call it get calculator. For now, we're going to return a new tax calculator 2019. Now in our main method, we're going to call the get calculator method and store the result in a variable called calculator. So in this method, we have a dependency or coupling to this interface. Now this interface is very simple. It's very lightweight. All it has is a method called calculate tags. As long as we keep the signature of this method exactly as is, we're not going to have a breaking change. This is how we achieve loose coupling. So with this style of programming, if we go to our tax calculator 2019, and let's say add a new method here, public float, calculate, insurance. We have changed this class, but this change is not going to impact our main method over here, because we're programming to an interface, not a concrete implementation. Now, if you have been paying close attention, you might say, but Mosh, over here, we are newing up a tax calculator 2019. So if you make any changes in this class has to be recompiled, and that means the main class should also be recompiled. That is true, but this is a very simple example to demonstrate this concept. In a real enterprise application, we're not going to write code like this. We use what we call a dependency injection framework that gives us real implementations of an interface. So in our code, we work with interfaces. Now, if this concept is new to you, don't worry, we're going to talk about this more and more throughout the course. So you learned the basics of classes and interfaces. Over the next few videos, we're going to talk about the 4 core principles of object-oriented programming. It's easier to explain it using a real example. So in this project, I'm going to add a new class called account. This represents a bank account. Now here we need a field for storing the balance of this account. So public float balance. Now with this implementation, we can go to the main class and create a new account. Now we have repeated the class name twice, so it's better to use the var keyword over here. Now with this implementation, we can set the balance to any amount. We can set it to a positive value or a negative value. But what if negative balances are not allowed in our application? We shouldn't be able to write code like this. In other words, we shouldn't allow other classes like the main class to change the state of this object directly. They shouldn't be able to change the data in this object. So to solve this problem, we go back to our account class and replace this public keyword with private. Public and private are examples of access modifiers. Many other object-oriented languages have the same concept. Now, back in the main class, we have a compilation error because we cannot access the balance field from outside of this class. It's hidden inside this class. So within this class, we can use it anywhere, but we cannot access it from outside of this class. But what if we really need to change the balance? How are we going to be able to do that? Well, here in the account class, we can add a method, public void set balance. We give it a parameter called balance. And here we set this.balance to balance. Now, because we have a method here, in this method, we can perform some kind of validation. So before setting the balance, we can make sure it's a positive value. So if balance is greater than 0, then we can set it. Now, a better implementation is to throw an exception or an error if the balance is an invalid value. But let's not worry about that. We don't want to do too much Java in this course. We want to stick to the basics. This is what we call a setter, a method that is used for setting the value of a field. By the same token, we can have a getter. So if we want to read the value of the balance field, we can call a method called getBalance. So public float getBalance. And here we return the value of the balance field. This is the encapsulation principle in action. So encapsulation is really about bundling the data and methods that operate on the data within one unit or one class, and hiding the values or state of an object inside the class. So with this, we can create robust applications. We can prevent our objects from going in an invalid state. So this is the encapsulation principle. Now, we can take this to the next level. Instead of this method, setBalance, it would be better if we had methods like withdraw and deposit. So instead of setting the balance to some kind of random value, it's better to record some kind of transaction so we know when we deposited or withdrew money from this account. So let's add a new method, public void deposit. We give it a parameter called amount. And then we can set this.balance to this.balance plus amount. Or in Java, we can use the augmented assignment operator. So we can rewrite the statement like this. This.balance plus equals amount. These two statements are identical. Now in this case, we don't even need the this keyword because our parameter is called amount. So that is better. Of course, here we need to do some kind of validation as well. We want to make sure that amount is a positive value. So if amount is greater than 0, then we update the balance. Similarly, we're going to add a method called withdraw for taking money out of this account. Once again, we add our validation logic. If amount is greater than 0, then we reduce the balance by this amount. This is a better implementation. So let's get rid of the setBalance method. Now from the main method, instead of setting the balance to some random value, we can use the deposit or withdraw methods that we created. So initially, we deposit $10 into this account. Then we withdraw $5. Finally, we get the balance and print it. So SOUT tab, that's our print line statement. And here we can call account.getBalance. Let's run the program. And the balance is $5. Beautiful. So this is all about encapsulation. Next, we're going to talk about abstraction. Now let's talk about the second principle of object-oriented programming, abstraction. Abstraction means that we should reduce complexity by hiding unnecessary details in our classes. Let me give you a metaphor. Think of the remote control of your TV. This remote control has a bunch of buttons that allow you to work with your TV. Inside the remote control, you have an electronic board, a bunch of transistors, and so on. Now, we don't directly work with these transistors. They're implementation detail. There's so much complexity there. We don't want to worry about that complexity. We don't care what happens inside that remote control when we press the turn on button. This is the abstraction principle in action. So the abstraction principle says that we should hide the unnecessary details in our classes, and this helps us reduce complexity. Let's say this in code. Let's say we want to implement a class for sending emails to our users. So let's add a new class. We call this mail service. In this class, we need a method for sending an email. So public void send email. Now in a real application here, we should have a parameter of type email, but let's not worry about it in this demo. Now, as part of sending an email, there are a number of things that should happen under the hood. We have to connect to a mail server. We have to authenticate. We have to send the email and then disconnect. So we could have a method like connect. In this method, we simply print a message like connect. Similarly, we can have a method called disconnect. And here we print this message. And let's add one more method, public void authenticate. Here we're going to send our username and password to the mail server. So let's say authenticate. Now, in our send email method, we're going to call these methods one by one. First, we're going to connect. Then we're going to authenticate. Next, we're going to send the actual email. And finally, we're going to disconnect. Now let's use this in our main class. So over here, let's create a mail service and set it to a new mail service. Now, look at the interface of this class. And by interface, I'm not talking about the interface construct in Java. I'm just talking about the interface of a class, like the interface of a remote control. What we see on that remote control, or what we see in this class. Here we have 4 methods, but the first 3 are implementation detail. We don't care about this. We don't care about connecting to a mail server. We don't care about authentication. All we care about is the ability to send an email. So these 3 methods are adding extra complexity to this class. They're making it harder for the consumers of this class to use this class. So we applied the abstraction principle. We go to our mail service and make these methods private. Now they are implementation detail and they're hidden from outside of this class. One more time. We make this private and one last time. Now, back in the main class, look at the interface of this class. It has a single method. It's much easier to use. It's like a remote control with only 4 buttons. Have you seen how hard it is to use one of those remote controls that have 50 buttons? You really don't know how to use them. If you want to change the volume, you have to look all over the place. Now, this mail service class has a single method. It's very easy to use. And more importantly, if we change any of those private methods, the main class is not going to get affected. So if I introduce a parameter in this method, let's say timeout, the only breaking change that we have is over here. The main class is not affected because the main class cannot see the connect method. This is the benefit of applying the abstraction principle. We can change the implementation detail without affecting other classes in our application. Next, we're going to talk about inheritance. Let's talk about the third principle of object-oriented programming, inheritance. Inheritance is a mechanism for reusing code. Let's say we want to build a GUI framework, a graphical user interface framework. In this framework, we want to have classes like textbox, button, checkbox, and so on. Now, all these classes should have some common behavior. For example, we should be able to enable or disable them. We should be able to set their focus. We should be able to set their position and so on. Now, when implementing these classes, we don't want to implement these behaviors in every single class. That's a lot of code duplication. Inheritance is a mechanism that allows us to reuse code across our classes. So we can implement all these common behaviors in a parent or base class, and then have all these other classes inherit those behaviors. Let me show you. So let's add a new class. We're going to call this UI control. That's the base or the parent class for all widgets on the user interface. Now in this class, we want to have the ability to enable or disable a control. So a method called enable. And here, let's just print a message called enable. Now let's create a textbox class. So we add a new class called textbox. We want this class to inherit the code that we wrote in the UI control class. So over here, we type extends UI control. Now we can go to the main class and create a textbox object. So var textbox, we set it to a new textbox. Now take a look. Here we have the enable method. We didn't implement it in the textbox class, we implemented it in the UI control class. But the textbox inherited this code from its parent. Now when we run this program, we can see the enabled message. Beautiful. Now, there is more to inheritance than we can cover in this video. I've dedicated an entire section about inheritance in the second part of my Ultimate Java series. So if you want to learn more, go watch that course. Next, we're going to talk about polymorphism. Let's talk about the fourth principle of object-oriented programming, polymorphism. Poly means many, morph means form. So polymorphism means many forms. And it's basically the ability of an object to take on many forms. Let me show you this in code. So continuing with our GUI framework, we want to have the ability to draw each widget on the screen. So in our UI control class, let's add a method public void draw. Now this method is not going to have an implementation because we don't know how to draw a UI control, because the algorithm for drawing a widget is specific to the type of the widget. Drawing a text box is different from drawing a checkbox. So we can leave the implementation empty, or better, we can declare this as abstract. So public abstract void draw. Now we have a couple of compilation errors. The first one is here because an abstract method cannot have a body. So we remove the braces and terminate this with a semicolon. This is like a method that we declare in an interface. It's only a method declaration. It doesn't have implementation. Now, because we have an abstract method in this class, we should declare this class as abstract as well. This is like a half-baked cake. We cannot use it directly. We cannot instantiate it. We cannot create a new instance of the UI control. We can only extend it. Now, if you go to our textbox class, we see a compilation error because this class has not implemented the draw method of the UI control. So we put the caret over here, press Alt and Enter, and implement methods, exactly like how we implement the methods of an interface. So now we have this public void draw method. Over here, let's print drawing a text box. Now let's add another class in this project. New class. We're going to call this checkbox. This class should inherit all the code from the UI control. So we type extends UI control. Then we have IntelliJ implement the abstract methods of this class. There you go. Now we print drawing a checkbox. So each widget knows how to draw itself, okay? Now, in our main class, let's add a public static method, public static void draw UI control. We give it a parameter of type UI control. And in this method, we call control.draw. Now, in our main method, we're going to call this method. So draw UI control. Now, the UI control class is the parent or the base of the text box and checkbox classes. So every text box is a UI control and every checkbox is a UI control as well. So when calling this method, we can pass a new instance of the text box class and run the program. Here we see drawing a text box. If we pass a new checkbox, we see drawing a checkbox. So even though in this method we are working with a UI control object, at runtime, this object can take on many different forms. It can behave like a checkbox or a text box or a button and so on. This is polymorphism in action. So an object can take on many different forms. That's all about polymorphism. So we have covered all the essential object-oriented principles. Next, we're going to talk about UML, which is the graphical notation we're going to use throughout this course. Now that we have covered the essentials of Java, let's talk about UML. UML is short for Unified Modeling Language, and it's a visual language that we use to model our systems. We're going to use it throughout this course to represent our classes and their relationship. Here are a few examples. This is how we can represent a class in UML. So we have this rectangle. On the top, we have the name of the class. In the middle section, we have the fields, and down below, we have the methods. So here we have a class called shape. In this class, we have a field called position x, and the type of this field is integer. So after the colon, we specify the type of a field or a parameter or the return type of a method. So here we have a method called render. It doesn't have any parameters. That is why we have an empty pair of parentheses, and it doesn't return any values. So we don't have a colon after the name of the method. So that means the return type of this method is void. Now this minus sign means this field is declared as private. You can see that over here. And obviously the plus sign means this is declared as public. Now in this course, we're assuming that all of our fields are private and all of our methods are public. So in the future diagrams, I'm not going to display the minus and plus signs to keep things simple. So this is how we can represent a class in UML. Now let's talk about the three types of relationships between classes. This is what we call the inheritance relationship. So this diagram is saying that the rectangle class inherits from or extends the shape class. You can verify that over here. So class rectangle extends shape. Now, more accurately in UML, the inheritance relationship is indicated by an arrow with an empty triangle. But in the software I'm using, we don't have such an arrow. So I'm going to display my inheritance relationships with an arrow with a filled triangle. Okay. Now let's talk about the second type of relationship between classes. This is called the composition relationship. It's indicated by an arrow with a diamond. So that means the shape class is composed of the size class. In practical terms, that means in the shape class, we have a field of type size. So the shape class is composed of the size class. As another example, you can say the car class is composed of the wheel class because every car has 4 wheels. Now in UML, we have another type of relationship called aggregation, which is kind of similar to composition, but I don't want to bring too much UML in this course. We want to keep things simple and focus on design patterns. So if you have some background in UML, you may argue that here we should use an aggregation relationship instead of composition. Let's not worry about these subtle details. So this is the composition relationship. Now let's talk about the third type of relationship between classes. This is what we call the dependency relationship. It's indicated by a dashed arrow. So that means somewhere in the shape class, we have a reference to the document class. Here's an example. In the shape class, we have a method called render, and this method has a parameter of type document. So document is not a field in this class, but it's used somewhere in this class. In this case, it's a parameter, but it could also be a local variable defined in the render method. So somewhere in the shape class, we have a reference or a dependency to the document class, okay? So here are the three types of relationships we're going to use in this course: inheritance, composition, and dependency. Hey guys, Mosh here. I just wanted to let you know that this video you've been watching is the first hour of my Ultimate Design Patterns course. In this YouTube video, we talk about 2 design patterns, but my Ultimate Design Patterns course includes over 20 design patterns. These are the design patterns that every software engineer must master. So if you want to learn more, I highly encourage you to enroll in my Ultimate Design Patterns course. The first 200 students can get the course with a big discount. I'll put the link down below if you're interested. The first design pattern we're going to talk about is the memento pattern. We use this pattern for implementing undo mechanisms. Let me show you. First of all, I'm going to add a new package to this project. So new package. We call this memento. This is where we're going to write all the code for this pattern. Now, let's say we want to build a code editor that supports the undo mechanism. So we add a new class in this package. We call it editor. In this class, we need a field for storing the current content of the editor. So private string content. We also need a getter and a setter for this field. Now, we don't have to type these manually by hand. We can have IntelliJ create these for us. So we put the caret on the field name, press Alt and Enter, and select Create Getter and Setter for Content. There you go. So here's our editor class. Now, before talking about the memento pattern, I want you to spend 10 to 15 minutes and think about a solution to implement the undo feature in this class. So in our main class, we should be able to create a new editor. Let's say editor equals new editor. Then we should be able to set the content a few times. Let's say A, then B, and C. And then we should be able to undo the content. So spend 10 to 15 minutes and think about a solution to implement this feature. This is extremely important because I want to teach you the art of problem solving. Unlike other courses, I'm not going to give you a UML diagram saying, this is the memento pattern and this is how it works. I want to take you through the same thought process that Gang of 4 have been through, so you understand how and why they came up with the memento pattern. So spend 10 to 15 minutes and propose a solution. When you're done, come back to the next lesson. All right, here's our editor class with the content field. Now, to keep the screen clean, I didn't add the getter and the setter that we created in the last video. Now, the simplest way to solve this problem is by introducing a new field called previous content. So every time we want to change the value of the content field, we store the current value in the previous content field and then change the content field. That's a very simple solution and it works. However, with this approach, we can only undo once. If you want to be able to undo multiple times, we need a list. So we should rename this field to previous contents, note the plural name, and the type of this field is going to be a list. That's a reasonable solution. Now, what if sometime in the future, we introduce a new field like title? So our editor window is going to have a content and a title. Now, to support the undo mechanism, we need another field like previous titles to keep track of all the changes to the title field. Now, as you can see, this solution is not very extensible. Every time we introduce a new field, we need to add an extra field for storing all the changes to that field. So we need to come up with a better solution. Now, let me remove these 2 fields. Okay, that's better. So instead of having multiple fields in this class, we need a separate class like editor state. This class will be purely responsible for storing the state of our editor at a given time. Currently, we have only one field in this class called content. In the future, we can add title and other fields. All these fields are going to be in a single class, okay? So in our editor class, we need to store a list of editor states. So we need a composition relationship between these 2 classes. And that means we should rename this field from previous contents to previous states. So we have a list of editor states inside the editor class. Beautiful. Now, this is a better solution because it allows us to undo multiple times and we're not going to pollute the editor class with too many fields, okay? However, this solution is violating a very important principle in object-oriented design. That is the single responsibility principle. That basically means every class should have a single responsibility. Let me give you a metaphor. Think of a restaurant. In a restaurant, every person has a specific role. They do a single thing. The waiter is purely responsible for taking orders. They don't cook for you. Now imagine a restaurant where the waiter takes your order, he cooks for you, he goes shopping, he also does taxes. It doesn't make sense. A restaurant like that is going to be very unmanageable. We have the same situation in software. To build maintainable software, we should design our classes in such a way that they have a single responsibility. Now back to our design. Our editor class currently has two responsibilities. One of them is state management. The other is providing the features that we need from an editor. We need to take all the state management work outside of this class and put it somewhere else. So we shouldn't have this field inside this class, previous states. Let's delete this. That means we're not going to have an association with the editor state class. So delete, that's better. We need to introduce a new class called history. This class will have a single responsibility, and that would be state management. So it will keep track of the changes in the state of the editor, okay? Now in this class, we need a field called states. This is the field that we previously had in our editor class, okay? So we have this field here, and that means we're going to have a composition relationship with the editor state. The history class is going to store 0 or more editor state objects in a list, okay? We also need two methods, push and pop. With push, we add a new state in the history, and with pop, we remove and return the last state. Now, technically, we could use a stack here instead of a list, but that's implementation detail. Let's not worry about it too much at this stage. Now that the editor class no longer stores state objects internally, we should give it two new methods, create state and restore state. The create state method stores the current state of the editor inside a state object and returns it. So we call this method and say, hey, save your current state and give it to me. We'll get an editor state object. Then we call the push method of the history class and say, hey, history, save this state. This is how these classes collaborate, okay? The restore method takes a state object and brings this editor back to that state. So it will reset its fields based on what we have in the state object. Now look at the type of relationship we have between the editor and the editor state classes. We have a dependency relationship. That means the editor class uses the editor state because the create state method returns an editor state object, okay? Well, congratulations! You came up with your first pattern. This is called the memento pattern. We use the memento pattern to implement undo mechanisms in our classes. Now here's our representation of the memento pattern. But if you look at the Gang of Four book or any other courses or books on this topic, you will see different names for these classes. The editor is called the originator, the editor state is called the memento, and the history is called the caretaker. These are just some abstract names that Gang of Four came up with to demonstrate the concept. It doesn't mean you have to use them to name your classes. Always use meaningful names for your classes. So this is the memento pattern. In this pattern, we have 3 participants or 3 players, originator, memento, and caretaker. Now that you understand this pattern, let's go ahead and implement it in code. All right, first of all, in the memento package, let's add a new class. We call this editor state. Currently, we need only a single field in this class. So private string content. It would be nice to initialize this field from the constructor. So we can press Alt and Enter and add a constructor with a parameter. There you go. So we have a constructor. This constructor has a single parameter. And in the body of this constructor, we initialize this field with the value of this parameter. Pretty simple. Now, I would prefer to declare this field as final. This will make sure that once we initialize this field, we cannot accidentally change it in our program. So this will add robustness to our code. Now we also need a getter here for reading the value of this field later on. So Alt and Enter and create getter for content. That's it. We're done with this class. Now let's go to our editor class. Here we need 2 new methods, create state and restore. So public editor state, create state. When we call this method, the editor will save its current state inside an editor state object and return it. So return new editor state, and here we pass the value of the content field. Now let's create the restore method. That is pretty easy. Public void restore. We give it a state object. And here we set the content field to state.getContent. As simple as that. The last piece of the puzzle is the history class. So in this package, let's add a new class. We call it history. Here we can use a stack or a list. I don't want this course to be very Java specific, so I'm going to go with a list. Private list of editor state. Now, what is going on here? Well, this list is an interface that is declared in the java.util package. So first we need to import it, otherwise the compiler doesn't recognize it. We can press Alt and Enter, and IntelliJ imported it on the top. So import java.util.list. Now, this list interface is a generic interface, which means we can use it to build a list of different types of objects. We can have a list of strings, we can have a list of integers, a list of editor states. So with these angle brackets, we specify the type of objects we want to store in this list. In this case, we want to store editor state objects, okay? Now, let's call this field state and set it to new array list. What is going on here? Well, I told you that this list is an interface that is declared in the java.util package. In this package, we have a class called ArrayList that implements this interface. So we're programming to an interface. Because the ArrayList class might have other methods that we are not interested in, we only need the functionality that is declared in the list interface, okay? Now, here we need two methods, push and pop, public void push. It takes an editor state object. And here we call states.add state. This will add the state object at the end of the list, okay? Now, public editor state pop. Here we need to calculate the index of the last item in this list. That is very easy. So var last index. Now the list interface has a method called size. This returns the number of items in this list. Now the index of the first item in the list is 0. So to get the index of the last item, we should get the size and reduce it by 1. Now we get the last item, or last state. That's better. States.get. With this, we can get an item at a given index. So let's get this item. Then we need to remove it from this list. So we call states.remove and pass the last state object. And finally, we return the last state from this method. That is our history class. Now, let's put all of this together and see the undo mechanism in action. So here in the main method, first we create an editor object. Next, we create a history object. So var history equals new history. Here we set the content to A. At the same time, we want to save the state in the history. So we call editor.createState. This will return the current state. And we'll add it to our history. So we call history.push with this object. As simple as that. One more time. We set the content to B, and right after that, we save the state in the history. Next, we set the content to C. Now here we can undo. So we call history.pop. This will return the previous state. And then we'll give this to our editor. So we say, hey, editor, restore yourself with this state, like this. Now, if we print the current state of the editor, it should be B. Take a look. So print editor.getContent. Take a look. We get B. If you undo one more time, we're going to see A. So let's duplicate this line. Now run. There you go. So this is how we implement the memento pattern. In this section, we're going to talk about the state pattern. Let's say we want to build a drawing application like Photoshop. In Photoshop and in many other applications, we have a palette of tools over here. And this canvas behaves differently depending on the tool that we select. For example, if we select the selection tool, you can see the icon of the cursor changes. Now, when we click and drag, we see this dashed rectangle. Similarly, if we select the brush tool and click and drag, we see this orange line. So basically, this canvas object is responding to mouse events like mouse up and mouse down, but what it does changes depending on the currently selected tool. Let's simulate this in code. So in this project, first I'm going to add a new package, state. We're going to write all the code for this section in this package. Now here we need a new class called canvas. This class should respond to mouse events like mouse down and mouse up. So here we need two methods, public void mouse down, and I'm going to duplicate this and rename the second one to mouse up. Now in both these methods, we should do different things depending on the currently selected tool. So first we need to figure out what is the currently selected tool. We can represent that using an enum. An enum in Java is like a set of constants. Let me show you. So in this package, we add a new class. First, we change the kind from class to enum, and then call it tool type. Now here we need to define a few constants, like selection. Note that I'm using uppercase letters to name this constant. This is a convention in Java. So this is our selection tool. We also need a brush and an eraser. Now, back in our canvas class, here we need a field to store the currently selected tool. That is really easy. So private tool type current tool. We also need a getter and a setter for this field. So we put the caret over here, press Alt and Enter, and create getter and setter. Beautiful. Now in our mouse down method, we should write code like this. If current tool equals tool type dot selection. Here we should change the icon of the cursor to the selection icon. So we simulate that by printing something on the terminal. Selection icon. Now, else if current tool equals tool type dot brush, then we're going to print a different message. Brush icon. One more time. Else if current tool equals tool type dot eraser, then we're going to print eraser icon. Now, we need similar code in the mouse up method. So to save time, I'm going to copy this and then paste it over here, and then change what we print on the terminal. So the moment the user releases the mouse button, if the current tool is the selection tool, we're going to draw a dashed rectangle. So draw dashed rectangle. If the current tool is brush, we're going to draw a line. And if it's an eraser, we're going to erase something. Okay. Now we could also implement this using a switch and case statement. Now, if you have been programming for a while, you have probably seen patterns like this in your code. You have a long list of if and else or switch and case statements. And you have probably repeated these statements in different places in your code. So in this example, we have these decision-making statements in these two methods. Chances are, in a real application, in a real drawing application, we should also respond to keyboard events like key up and key down. And we probably have to repeat all this decision making inside those methods as well. So the approach that we have taken is not maintainable. The more tools we support, the longer these decision making statements are going to be, and maintaining this code is going to become really difficult. Also, here we have the lack of extensibility. It's not easy to extend this application. Let's say tomorrow we want to add a new tool for drawing a circle. We have to go to different parts of our code and make changes. For example, in our mouse down method, we should add another else if statement to see if the current tool is the circle tool. Then we change the icon to the circle icon. We have to make a similar change in the mouse up method. So extending this application is not easy. Now, what we really need here is giving the canvas the ability to behave differently based on the currently selected tool. So in both these methods, we're executing different code depending on the currently selected tool. We want this method to behave differently depending on the current tool. Earlier in the course, we talked about the 4 essential principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Which one of these principles do you think we can apply here to solve this problem? I want you to spend 10 minutes on this exercise and figure out a way to solve this problem. When you're done, come back, watch the next lesson. Earlier in the course, we talked about polymorphism. I told you that polymorphism is a mechanism that allows an object to take on many different forms. So earlier we built this UI control class. We declared this as abstract because it has a single abstract method. Abstract methods are methods that have no implementation. So here we have a draw method, but we don't know how to draw a UI control. The drawing algorithm will be dependent on the type of the UI control. So we created two specific UI controls. One of them was the text box class, which extends the UI control. And this is where we're implementing the logic for drawing a text box. Now, in our main class, we had code like this. We declared a static method called drawUIControl, which takes a UI control and simply calls control.draw. Now, depending on the type of the object that we pass to this method, our application behaves differently. This is polymorphism in action. So if we pass an instance of the textbox class, the draw method of the textbox class will be called, even though we're working with the UI control class here. So this control object can take on many different forms. This is polymorphism. Here's the UML diagram of these classes. So our main class talks to the UI control, which is the parent or the base of these two classes, textbox and checkbox. In UI control, we have an abstract method called draw, and we have implemented this method in our child classes. Now we can use the same technique to get rid of those ugly if and else statements in our canvas class. So here's our canvas class. We have the current tool field and these two methods. We want these methods to behave differently depending on the current tool. So we introduce a new class called tool. This is going to be an abstract class like our UI control. In this class, we're going to declare two abstract methods, mouse up and mouse down. What happens when the user releases the mouse button will be determined in child classes. So we introduce new classes like selection and brush. And in these classes, we're going to implement the logic for mouse up and mouse down events. Now, our canvas class is going to work with the abstract tool class. It doesn't care about any specific tools, but it will behave differently depending on the specific tool that we give it at runtime. And this is what we call the state pattern, because the state pattern allows an object to behave differently when its state changes. Now, if you look at the classic definition of the state pattern in the Django 4 book or other books and courses, you're going to see different labels. So instead of canvas, we have context, and instead of tool, we have state with two concrete implementations. Also, instead of mouse up and mouse down methods, we have the request method that is handled by the state class. So as I told you before, this is just an abstract concept. It doesn't mean you should name your classes context or state. They're too abstract. Always use meaningful names that fit the domain of your application. Next, I'm going to show you how to implement the state pattern in code. So here in the state package, let's add a new class, tool. In this class, we need two abstract methods. So public abstract void, mouse down, and mouse up. Now, because these methods are abstract, we should mark the class as abstract as well. Now, we could also use an interface here, because an interface is simply a contract that determines the capabilities that a class should provide. So earlier you saw that the methods in an interface don't have an implementation. They're exactly like our abstract methods here. Now, what is the difference between an interface and an abstract class? Well, they're both abstract concepts. We cannot instantiate them. We cannot create a new instance of this tool class or the tool interface. So because they're abstract and don't have much code, they allow us to build loosely coupled applications. We prefer to use an abstract class if you want to provide some common code to all the child classes. In this case, we're not providing any common code to our tools, so I'm going to replace this abstract class with an interface. Take a look. Public interface. Now in interfaces, we don't need the abstract keyword because these methods are considered abstract by default. So we remove the abstract keyword. Also, these methods are considered to be public, so we don't need the public keyword either. That makes our code cleaner. So we have an interface for representing a tool. Now, let's implement specific tools. So let's add a class called selection tool. Here we type implements tool. Now note that here we have two interfaces with the same name. The first one is the one that we just created. We also have a tool interface in Java X package. Don't worry about that. Let's import the interface that we created. Okay. Now we should implement this interface. So we press Alt and Enter and implement these methods. So this is where we implement the logic. With the selection tool, when the user presses the mouse button, we should change the icon to the selection icon. And when they release the mouse button, we should draw a dashed rectangle. Okay. Now let's add one more class. This one is going to be our brush tool. Brush tool also implements the tool interface. Here we have a different logic. So when the user presses the mouse button, we should display the brush icon. And when they release the mouse button, we should draw a line. Now let's see how we can incorporate these into our canvas class. So let's open up the canvas class. First, we should change the type of this field from tool type to tool. So we are programming to an interface, okay? Now we have a bunch of compilation errors. It doesn't matter. We're going to delete all the code in these methods. All this nasty, disgusting code. Now, we should change the return type of our getter. Instead of tool type, we're going to use tool. And similarly for our setter, we're going to pass a tool object. Beautiful. Now, in our mouse down method, we're going to call current tool dot mouse down. And similarly, here we call current tool dot mouse up. That's all we have to do. Isn't this code beautiful? So the canvas class is simply delegating to a specific tool to determine what should happen when the user presses or releases the mouse button. With this implementation, we don't have a long list of decision-making statements, so our application is more maintainable. And we can also easily extend it. Let me show you. So right now, we only have two types of tools, a selection tool and a brush tool. Let's use this, and then I'll show you how to extend this application to support a new tool. So we go to our main class. First, we create a canvas object. So canvas. Now, we set the current tool. Set current tool. Here we should pass an object that implements the tool interface. So we can pass a selection tool. Then we call mouse down and finally mouse up. Let's see what happens. So the icon changes to the selection icon, and then we draw a dashed rectangle. Beautiful. If we pass an instance of the brush tool class, we'll get different result. There you go. Now, let's say tomorrow we want to support a new tool. That's really easy. All we have to do is to add a new class that implements the tool interface. Take a look. So here, I'm going to add a new class. Let's say eraser tool. We have this class implement the tool interface. And over here, we implement our logic. So eraser icon. And here, erase something. Now, we go back to our main class and simply pass a new instance of the eraser tool class. Take a look. We get different result. And that brings us to a very important principle in object-oriented programming, open-close principle. That basically means our classes should be open for extension, but closed for modification. So we're not allowed to change the code in our classes. We can only extend it. Now, with this principle, we can add new functionality without changing the existing code. We can support new functions by adding new classes. Now, why does this matter? Well, how many times have you found yourself changing the code in a class and then breaking something in your application? The open-close principle prevents situations like that. Every time we want to support a new feature, we simply add new classes and we test those classes, okay? So following this principle makes our applications extensible and robust. If this concept is new to you, don't worry, you're going to see more examples of this later in the course. So design patterns are great. They help us build maintainable, extensible, and reusable objects. However, sometimes they get misused. Here's an example. We've got this guy over here. His name is John Smith. He's a fairly arrogant developer. You've probably seen him in my other courses. He recently learned about design patterns and started refactoring some existing code to apply these patterns. Now he feels superior to his coworkers. He feels like a superstar developer just because he learned about this state pattern and applied it in code. That is what I call abusing patterns. Remember this, every pattern has a context. It's there to solve a particular problem. And that's why I've taken a problem-driven approach in this course, so you learn and understand when and how to apply these patterns. If you just blindly apply these patterns in your code, you're going to increase complexity because you're going to end up with more moving parts. So not only haven't you solved a problem, but you actually created a new problem. You created what we call a design smell in your application. That is an application with an overly complicated design. Some people call it over-engineered. I don't like to use that term because a real engineer always tries to understand a problem first, and then they think of various solutions and pick the one that best fits the problem. That is the definition of an engineer, at least for me. Over-engineering a solution is what code monkeys do. Programmers who blindly write code without understanding the problem they're trying to solve. As Leonardo da Vinci said, simplicity is the ultimate sophistication. So keep things simple and pragmatic. Don't blindly apply these design patterns without understanding the problem you're trying to solve. Next, I'm going to show you a real example of abusing the state pattern. All right, let me show you how the state pattern can easily be abused. Let's say we want to implement a stopwatch app. In this app, we need a stopwatch class with a click method. When we click it, it either starts counting or stops. So in our state package, let's add a sub package. I'm going to call this abuse. Now in this package, we're going to add a new class called stopwatch. Here we need the click method. Now, depending on the state of this object, we should do different things. We can represent the state with an enum with two states, or we can use a Boolean. I think a Boolean is easier, so let's go with a Boolean. So private Boolean is running. Now, when we click the stopwatch, if it's running, then we're going to stop it. So we set is running to false, and then we print stopped. Otherwise, we're going to set is running to true, and then print running. Let's test our implementation up to this point. So in the main class, we create a stopwatch, and then click it. Initially, it stopped. So when we run this application, we should see the running message. There you go. Beautiful. Now, if we click it one more time, we see two messages, running and then stop. If we click it one more time, we see running, stopped, running. Beautiful. So this is a very simple, straightforward implementation. Now, John Smith takes over this code. He's sitting in the office and he thinks, the click method is behaving differently depending on the state of the stopwatch. So that is the case for the state pattern. He's going to refactor this code like this. First, he's going to create a new class or an interface called state. So we need an interface here. This interface is going to have one method, click, and we're going to have two classes that implement this interface. So John adds two classes. One of them is stopped state. The other is running state. Running state. Now, both these classes should implement the state interface. If the stopwatch is running, we should stop it and then print a message. But how are we going to be able to stop the stopwatch? We don't have access to the stopwatch object here. Well, we can add a constructor. So public running state. We give this constructor a parameter of type stopwatch and then store it in a field. So we declare a private field here, private stopwatch. We call it stopwatch, and we initialize it in the constructor. This.stopwatch equals stopwatch. Now, in the click method, we should change the state of the stopwatch. So first we need to go to the stopwatch class and add a field to store the current state of this object. So we don't need this field anymore. Let's declare a private field. of type state called current state. Now let's generate a getter and a setter for this field. That is super easy. There you go. So back to the running state. When we call the click method, we should change the state of the stopwatch. So we call stopwatch.setState. And here we pass the next state, that is the stopped state. So new stopped state. Now here we have a compilation error because this class doesn't implement the state interface. So let's add it real quick. Implements state. All right. Now back in the running state class, the problem is gone. Beautiful. So we change the state and then print a message saying stopped. Now we need a similar approach in the stopped state class. So here we generate a constructor. I'm going to show you a shortcut. If you're on Mac, press Command and N. If you're on Windows, press Control and N. With this, we can bring up the generate palette and generate a constructor. Now here we can add a parameter that is stopwatch. And at the same time, we can create and initialize a private field. So we put the caret on the parameter name, press Alt and Enter, and select Create Field for Parameter Stopwatch. There you go. So we got a private field, and this field is initialized over here. Beautiful. Now, in the click method, we should change the state of the stopwatch. So we call stopwatch. That's the current state. If it's stopped, we should set it to the running state. So new running state. Now here we should pass a reference to the stopwatch. That is the stopwatch field that we have in this class. Okay. Then we print a message saying running. Okay. Now we have a compilation error in the running state class because when we try to change the state of the stopwatch, we're passing a new instance of the stopped state class. The constructor of the stopped state class expects a stopwatch object. So we pass that object over here. Problem is solved. So we have two state classes. And the final part, we go to the stopwatch and replace this implementation with current state dot click. So we're delegating the task of clicking the stopwatch to the state object. And by the way, initially we should set this to the stopped state. So new stopped state. Now here we should pass a reference to a stopwatch object. That is going to be this that represents the current object. We're done. Now, back in the main method. So internally, we changed the implementation of the stopwatch, but it behaves the same way. Let's run the program. We see the exact same result as before. Beautiful. However, this implementation is way more complex than the simple if and else statement that we had before. So there is absolutely nothing wrong with if and else or switch and case statements. If you have a few decision-making branches in a single method, like how we did in the stopwatch class, we had those decision-making statements in a single place. There is absolutely nothing wrong with that implementation. But in our previous example, in our Canvas class, we had those decision-making statements in multiple places, in the mouse down and mouse up methods. And more importantly, if we wanted to support a new tool, we had to modify different parts of our code. That is the reason why we refactored this code, we changed the structure, and used the state pattern. In contrast, in the stopwatch, all the decision-making was in a single place, and we know that this stopwatch is not going to have a new state in the future. It's either stopped or running, as simple as that. So we don't have a maintainability issue here. We don't have extensibility issue. We ended up refactoring this code. Well, I didn't. John Smith did that. But he made this code overly complicated without gaining any benefits. Now we have more moving parts. We have an interface plus two implementations, and our logic is spread over these two different classes. In contrast, in the previous implementation, all that logic was in a single place. So here's the bottom line. Don't abuse the design patterns. Congratulations on completing this YouTube tutorial. As I told you before, this video is the first hour of my Ultimate Design Patterns course. If you want to learn more, I highly encourage you to enroll in my course where we talk about 20 other design patterns. These are the essential design patterns that every software engineer must master. The first 200 students can get the course with a big discount. So if you're interested, Enroll now before this offer expires. You can find the link below this video. Thank you and have a fantastic day.